So again, as a reminder, what we can do is with the quadratic function, we have this other form called the standard form, okay? And basically remember, wait, am I recording? Yeah, beautiful, good. And with that, remember, with that form, it's going to look something like this, right? You have a times x minus h squared plus k. Where again, the a is the same as in the other form, right? You know, so if the a here is positive, the graph opens upward. If a, however, was negative, it opens downward. The a cannot be 0, okay? And the hk, that point, is the vertex. You know, that's where the graph changes direction. But what's nice about this form also is if you know the vertex and you know a point on the graph, then you could find an equation for the quadratic function. Okay? Then you could write an equation for that. That's what, okay, so we did some examples last time. So what I'm going to do now is I'm going to, actually, you know what? We did do an example. I think we, if I remember correctly, I think we did this example last time. Okay, let me go through it again though. So here, because I did it for the other class also. Yeah, so here, okay, we want a quadratic function whose vertex is 2, 4, and it passes through the point 4, 7. Okay, again, I know I did this last time, but I feel better doing it again. So we want a quadratic function whose vertex is 2, 4, okay, and it passes through the point 4, 7. But we can find a quadratic function like that. I mean, you really could use the other form because we do have the formula for the vertex. You know, the x coordinate is negative b over 2a. I mean, you really could do that if you wanted to. It's just going to be a lot more work. So, okay, so the vertex is 2, 4. That means the point 2, 4 has to equal this point, hk. That's what it has to equal. And when 2 points are equal, they have the same x coordinates and they have the same y coordinates. So their x coordinates are the same and their y coordinates are the same. So in other words, you have 2 equals h, which is the same, of course, as h equals 2, right? You just interchange both sides of the equation. And we also have 4 equals k, right? Which amounts to saying k equals 4. Now that we know what h and k are, we have most of the function, so to say. Namely, we have f of x is a times x minus 2 squared plus 4. That's what we have here, as you can see. Okay. But again, are we done yet? Well, no, because we need a. But can we find a? Yeah, we could, because we know something else. We know that the quadratic function passes through the graph passes through the point 4, 7. So in other words, 4, 7 is on the graph. Well, what does that really mean? That means f of 4 must be 7. Okay? F of 4 must equal 7. So in other words, when x is 4, the entire expression here equals 7. Like over here. Okay, so we have 7 equals a times 4 minus 2 squared plus 4, which is equal to a times 2 squared plus 4, which of course is 4 times a plus 4. So really we have this equation to deal with. this a here is our unknown, our x, so to say. Well, maybe I shouldn't say that because x is up here, but this is our unknown. Let's find it. So I interchange both sides of the equation. I put 4a plus 4 equals 7. I mean, theoretically, you don't have to do that because, again, with an equal sign, what's on the left and what's on the right, they're equivalent, you know, the same thing. So we subtract 4 from each side. As you can see, we have 4a equals 3. So 4a equals 3. But we don't want 4a, we want a. So what do? Divide. Dividing both sides by 4, right? We get a equals 3/4. So from there, what we get is this. A is 3/4, and this is what our wonderful quadratic function looks like. Right? So again, this is the one whose vertex is 2, 4, and passes through the point 4, 7. And we could even check that actually. I did sketch the graph here, but I'm going to, which from Desmos, I'm going to sketch it in Desmos now as well, just to help you remember how to use Desmos, okay? But you can see that the graph satisfies our conditions. It's quadratic. It passes through it has vertex 2, 4, and it passes through the point 4, 7. Now let me do this for you guys since I did this for the other class. Let me graph it in Desmos. Again, it's free to use. All right, so let me stop sharing this. I got to share the, what do you call it, the Chrome tab. Here we go. All right. I'm in Graphing Calculator, so you can see that. So let's sketch this thing. We have f of x equals 3/4 times x minus 2. Wait, no, that's not right. 2? Oh, I was right. X minus 2 squared plus 4. I had to check because I thought I was wrong. So there we go. I mean, you can see that the graph is up here. Okay. So what we can do is you can click and hold, click and drag, I mean, excuse me, to move it down a bit. Then you can zoom in a little if you want. You know, zoom in. Like so. Now to make it even look better, you can see that the x-axis is below here. You can see the numbers. To really get those points though, here you can click in Desmos, okay? You can put the points in. We have 2, 4. You know, we label it, write it like a point. You can click label and it'll label the point for you. We also want 4, 7. So let's write that, 4, 7. Okay, as you can see, it showed up. Click label, boom, we got, no, click label. There we go, we got it. Okay, so you can see that, yes, we have the right graph. Good. Okay, are there any questions on this? Okay, let me get back to the notes then. Okay, so here we go. Right? Okay, so now here, this is where I want you to actually work on these now. Here you're going to solve these two examples where you find a quadratic function. I rewrote what was on the very first slide. I wrote that over here for convenience. Okay, so I want everyone to do these two problems. You should, yeah, everyone can see them. Okay, you know, take about 4 minutes to work on those. And if you don't finish, that's okay, but you know, please work on them. So I'm going to stop the recording.